Hello class, Vinayak here. Today we'll be going over a 1-2 addition of HBr to an asymmetric diene. So our first step in this case is we're going to want to number the diene, and we're going to number by placing the number 1 on the double bond that is least substituted. In this case, we're going to be numbering from left to right. So this will be 1, 2, 3, and then 4. And now we're going to know that this double bond is going to attack this H right here. And the electrons in this bond are going to go onto the bromine. And since this reaction follows Markovnikov's rule, we're going to form this carbocation. And we're still going to have Br minus in solution. So this Br minus is going to attack this carbocation right here, and we're going to get this final product. And if you notice here, a new stereocenter has formed. There's a hydrogen right here, but we didn't really indicate it, but it's there. So we're going to want to indicate stereochemistry. So it doesn't matter if we put a wedge or a dash, but we have to indicate it. So in this case, I'm going to put a wedge. I'm going to indicate a racemic mixture, which was going to be like this, plus minus. Now, this 1-2 addition of HBr to an asymmetric diene, it always happens is what we call a kinetic reaction, the reaction that forms the fastest. In this case, it will be kinetic, and kinetic means low temperature. So make sure to indicate here, cold. Now, this 1-2 addition always forms in a kinetic reaction, but it can also form in a thermodynamic reaction.
Hi guys, Dr. Breuer here. What we're going to do today is we're going to give you a quick tutorial on how to do a 1-4 HBr addition to a diene. Now Vinayak, I know, gave you the 1-2 addition, but now we're going to go over what to do in the 1-4 addition. So let's go ahead and get started with the board. Huh, that's weird. Let's just go ahead and flip this around. Vinayak, who's been in my office? Here, come help me clean this up real quick.
Oh, so sorry about this, Dr. Breuer.
Those Bruins. Thanks, Vinayak. Okay, alrighty class. So this is what we're gonna go ahead and show you how to do this 1-4 addition. So here, we have an asymmetric dienophile. Well, no, I'm sorry, not a dienophile, but a diene. So what we wanna do, of course, to first do this, is we know that we have an HBr addition. Now remember, that anytime you have a 1-4 addition, it's typically going to be a thermodynamic conditions, which means our other reagent is going to be warm, or heat, if you will, temperatures. So now what we first got to do is we got to go ahead and number our carbons, starting with the carbon that is least substituted. So on this side, 1, 2, 3, 4. And now what we want to do is we want to have this nucleophile attack this electrophile, and these electrons move here. Then what we're going to go ahead and do is we're going to show the mechanism and show exactly what that forms. Now keep in mind, this reaction, of course, still follows Markovnikov's rule, which all that means is the electrophile is going to go towards the carbon with the most hydrogens attached. And now what we form is we form this carbocation. Now, you have to remember that once we form this carbocation, a 1-4 addition is typically more thermodynamically favorable, which all that means is that your end product should be the most stable product. In this case, the more substituted double bond that you have, the more stable the product. Now, if you know, you can create some resonance from this, right? This double bond can move over here, and now you form this. With this carbocation right here. So the bromine doesn't immediately react with this in a thermodynamic condition, because what's first going to happen is this double bond is going to attack this electrophile right here and form this new resonance right here. So now, then you have the bromine, or the nucleophile in this case, if you will, finally attacking this right here. And now what you're going to form, and now you're going to go ahead and form your new end product, which looks like this. Okay. So this is going to be our final end product for the 1,4 addition. Now, keep in mind right here, since right here there's technically 2 hydrogens, so we didn't necessarily form a new stereocenter, and we don't need to indicate plus or minus because this isn't a racemic mixture. Now, just a couple ending notes is know that 1,4 does not necessarily always mean it's going to be the more thermodynamically stable product. Typically, in most cases, it'll probably be your more thermodynamically stable product. But as Vinayak mentioned earlier, sometimes your 1,2 kinetic product can also be your more stable, thermodynamically stable product. So just keep in mind, and quick note for you to tell whether or not what product is more stable is look at the double bond and see which is more substituted. Here, we know that the 1,4 addition is definitely the more thermodynamically stable because it is a tri-substituted double bond. So, there you have it, your 1,4 HBr addition to a diene.